Hi, everyone. Thank you for joining today. We're gonna wait for a minute or so before everyone comes in, but since we have a larger group, we're gonna have everyone muted just for now. But if you do have any questions, feel free to raise your hand. We'll get to your question, or you can also message in the chat. We'll respond to your question as well. So just gonna give it about a minute before the rest of the people come in, and then we'll get started. Yep, we're approaching around the 30 mark, so we'll get started now. So today we have Michelle, who's going to be presenting the topic of common heating, ventilation, air conditioning problems and solutions. And before that, we have a guest speaker, Vicky, who's going to be presenting, Michelle, can you go to the next slide, please? Who's going to be presenting the Save on Energy Business Program Suite. So just a few slides from Vicky.
Great, thanks. So I'm Vicky Gagno. I work at the IESO in demand side management, working on the business programs, and I primarily work with public sector and agriculture organizations. And I'll tell you about some incentives that are available through the Save on Energy programs. Next slide. So there are a lot of programs available to meet the needs of various size of customers operating across all the sectors. No matter how you do business, there's a program that can help you save energy, including prescriptive programs where there are incentives for specific efficient equipment installed, like the retrofit program. There are custom incentives based on the amount of energy saved, like EBCX and EPP. There's point of sale discounts, direct installation of measures, and training and coaching. And since today's webinar is focusing on HVAC problems and optimization, I'm going to mention two programs with that focus. So next slide. First is the existing building commissioning program, and it helps you get your building back to working the way it was originally intended and to optimize the facility operations and maintenance practices to improve building performance. There are incentives of up to $150,000 for hiring a qualified commissioning agent to recommission the buildings. So the incentives come in three phases. The first is the investigation phase, and it's to hire a commissioning agent to help identify the areas to optimize, and that's at 6 cents a square foot. And then after you implement the recommendations coming out of the investigation, you're incented at 3 cents a kilowatt hour for the savings. And then a year later, to ensure that the savings persist, you're incented again at 3 cents a kilowatt hour. So in reality, it's 6 cents a kilowatt hour, but it's just done in two phases. Next slide. Next is the Energy Performance Program, which is a comprehensive program designed for customers that actively manage their energy. And the incentives are based on achieving measurable energy savings over time. So once we agree on a baseline energy model, then at the end of the year, you're incented at 15 cents a kilowatt hour for electricity savings at peak hours and 4 cents a kilowatt hour for off-peak hours. And the savings are calculated by comparing your metered consumption to your facility's energy baseline. And you can continue to be incented for savings each year over 3 years. Next slide. But if you're interested in changing out equipment, the retrofit program is our largest program, and it's intended to help organizations replace inefficient equipment with more efficient equipment. There's a prescriptive stream with incentives for commonly installed equipment with known energy savings, including HVAC equipment, lighting controls, and VFDs. And for more unique solutions, the custom stream incents projects at $1,800 a kilowatt or 20 cents a kilowatt hour. Next slide. One of the biggest enhancements to the retrofit program this year is the expansion of incentives for solar PV across the province. There are two categories of incentives for solar PV. The micro generation up to 10 kilowatts is $1,000 a kilowatt. And for between 10 kilowatts and up to a megawatt, it's $860 a kilowatt. And this is for behind the meter on-site generation only. For load displacement, net metering isn't allowed. Next slide. For LED lighting, incentives are provided at the point of sale through the Instant Discounts program. You go to a participating distributor that can be found on our website. There are over 500 across the province. You purchase your lights. The discount is applied at the point of sale. There's no forms or applications needed. Next slide, final slide. Finally, there are incentives to hire an energy manager. So 50% funding up to $100,000. And this is in recognition that it takes people to identify the opportunities and implement active energy management. And in addition to the incentives to help hire an energy manager, there's training and coaching support and a cohort type strategic energy management initiative to work alongside other organizations of similar type. And there are also some incentives for energy savings that are not already incented by other Save on Energy programs that can help with metering and monitoring and all sorts of things. So lots of incentives no matter how you do business. And with that, I will turn it back over to Michael.
Thank you very much, Vicki. Well, good morning, everybody. So today we're going to talk about HVAC issues, electrical issues, some refrigerant and airflow issues, as well as preventive maintenance strategies. But this is an extremely wide topic. There is no way that we could cover all possible issues. So it's more about giving you some guidance maybe, and there's a little tool, Excel tool that will be provided to you also, which is right now quite limited, but again, it will give you, I'd say, kind of maybe a starting point, especially if you do an EBCX. Vicky was talking about EBCX, there's a program. The one thing I want to make clear about EBCX, sometimes you'll hear people say that EBCX is not there to fix maintenance issues or deferred maintenance issues. There's nothing further from the truth. Maybe in theory that's the case, but if you do plan on an EBCX, do plan to have that EBCX improve your preventive maintenance practices, maybe put in place. That would be actually a measure that would be part of the EBCX because the cost of it would be outside the scope of EBCX, but to have a preventive maintenance program if you do, and obviously to identify failures or failures that would happen in a short amount of time. So keep that in mind. EBCX is a good way to actually capture a lot of what we're going to talk today, maybe have some tools developed, customized to your building through that EBCX. So the objectives are to obviously identify some of the main failures of HVAC system. We will go to some very specific type of failures, but again, do not expect to cover all of the different possible issues you have because there's so many different type of HVAC systems, especially in the ventilation side of it. There's like so many different type of ventilation system that it's not possible to cover all of that. Obviously, typical disclaimer, because we're not dealing with a specific building, what we're going to present is, kind of best practices or the most common things. So don't use that as your diagnostic tool right away without obviously applying your judgment, your in-house expertise, your whoever worked for you in doing the diagnostic, because you need to obviously apply it to every building. So why do we have a session about mechanical issues? Well, HVAC systems are getting more and more complex, especially with the controls that are getting more and more complex. They're getting more efficient and at the same time more complex. In my recommissioning work, usually where I find the most issues is often in the more advanced building. When I deal with a LEED qualified building, it is not uncommon that it's often the building that has the most issues, not because it's not an efficient design, it's just because of the complexity, needs to have a very specific PM program. It has to have specific training for the operator. So such failures are often associated not with necessarily issues with the equipment, but more the complexity and how it's been handed over to the operating team. That disconnect that you often have between construction and O&M is even greater when you have complex systems, which we often see in a advanced high efficiency building. And I don't want to target LEED. You can have other buildings that have complex systems that are highly efficient and that will suffer the same type of issues. So we're going to start with some common mechanical and electrical issues. When I prepared a material, thank you, Purasant, for providing all of the structure for it. When I say electrical issues, I had red flags coming on right away, because when you deal with electrical issues, especially with building operators, you got to be very careful. You should never have building operators that may not be qualified as electrician try to diagnose and resolve most electrical issues, because obviously of the safety hazard related to any electrical work. Even though this is quite obvious, I still feel the need to repeat it. I've seen some work done during my recommissioning work where it should have been done by electrician, and sometimes done by electricians, but not done properly. And I just want again to highlight the danger of arc flash. Our buildings are usually three-phase voltage, and that's 575 volts. This is a very dangerous voltage. So even just opening a panel should never be done without proper PPE. And I've seen electrician work live without proper PPE, and you can get in trouble because of that. I put the link to it's actually an Australian video. It's very good. It's the danger of arc flash. So it's just to say we're going to talk about a few electrical issues that are common, but remember that this has to be done by electrician, and not only that, but by electrician that wear the proper gear if they work on live equipment. Ideally, they don't. It's all de-energized before they do any work. So keep that in mind when we get into this section about common electrical issues. So the most common issues will be, actually, I'm going to go past the blown fuses and trip breakers, because that would be very, very small load. I'll get back to that. But when you have electrical issues, will be very often with motor not starting. And if it's on the electrical side that the motor is not starting, because it could be on the control side, obviously, very often it will be related with the starter, with the capacitors that are part of there, because capacitors do age and deteriorate, and contactors, especially if you've got short cycling with a motor that starts and stops all the time, it gets really hard on the contactor or the relays, and they will actually eventually fail. Again, you will know the cause of it, and you can know what the effect is as an operating team. But when you get to the solution, you will not do that. You will get an electrician to do that for you. So if the system starts to fail to start, short cycles frequently, very likely it's going to be the contactor, the relays, that needs to be changed. What this little table provides you is really a quick diagnostic tool. Say, hey, I hear this humming from this motor, and it sometimes fails to start. That is likely the capacitor that are problematic. So if you've got small loads, obviously you could just have a breaker that flips, so you have to go back and reset the breaker, which can be done by your in-house staff without calling an electrician. But if it trips all the time, if you always have that, then you have a bigger problem. And you can adjust, obviously, most people will know that. You just don't reset all the time your breaker. If it trips all the time, that breaker actually will go bad also, because it has a number of limited trip that it can sustain, just like a breaker is not a switch. So you have to identify what the source of that overload is. And then usually that means, again, asking for an electrician to come in. So when we deal with electrical issues, you should have the proper tool in-house, so that especially the new operators, not obviously you've got some experienced operators that will know all of that, but new operators should be aware of what are the effect of those main issues that you have with electrical failures. Obviously, loose wiring, loose connections, that's something you have to be very aware of. One thing you could provide your team, and I'm going to try to show that to you. Actually, I'm going to switch screen so I can see the camera here. Just give me a sec. If you've got a little infrared, so here you see I'm doing an infrared of the screen. Well, you guys probably know that if you do infrared of your electrical panels, of where your contactors is, that is something that will provide you quick diagnostic that you need retorquing or that you have a potential overload in a circuit. And those little infrared cameras, you don't necessarily need to call an external resources. You can provide your team with that little infrared camera, and I'll show you. I use it for other diagnostics that we do to try to prevent failures. It's cheap. There's multiple brands that sell similar infrared cameras, and it will allow you to identify loose wiring before they become an issue. So something to keep in mind. Obviously, once you've got loose wiring, just like the other electrical issues, you don't fix that yourself unless you have proper qualification. That means retorquing that you may have in your panel. So there's different, obviously, solution to what you will diagnose, but that little infrared is very useful. The last line there says about thermostat malfunction. That is actually not that common in most commercial buildings because we don't actually use a lot of thermostat. In the smaller buildings that have rooftop units, you do have thermostat. Most of the medium to large size building have not thermostat, but BAS sensor. That's a whole different problem. When we have BAS sensors, it is not thermostat. But if you have a thermostat malfunction, even though the table says it could be miscalibration or sensor failure, it's usually failure. You do not typically calibrate a thermostat. You replace a thermostat. So there's usually a failure and you will replace that. That's kind of a no-brainer. But again, just a few items about, I'd say, the general electrical issues you may have. Now we're going to switch to motor fans and motor pumps. Because motor reliability is not about just the contactor starting the motor. It's also how you maintain that motor. Does your PM program have anything in regard with motors? From my experience, there's usually very little that is done with the actual motors in most PM programs. And sometimes for good reason, you do have limited resources. You do have to target the biggest potential issues, but you need to know a few things about motors. Motors do not like heat. So if your motor is not ventilated properly, if it's in an enclosure that's really hot, it will reduce its life expectancy significantly. Most of the motors we use in our buildings are what we call Class F motors. Class F, the different class of motors is about how hot the winding can run without reducing its life expectancy too much. So a Class F motor will run at its maximum temperature of 155 degrees for the winding temperature. The surface temperature will be typically 30 degrees lower. And by the way, that 155, it's rated for 40 degrees indoor temperature. So if your indoor temperature is 20 degrees, then your winding temperature should be 20 degrees less. So it should be at 135. And your surface temperature should be 30 degrees less than that 155. So should be 105. So if you do have, again, I'm going to show you that little infrared camera. If you have that little infrared camera, you could go around very quickly when your motors are running fully loaded, not when they're, if they have a VFD, not if they're at 20 hertz. And if you measure a surface temperature that's higher than, let's say, 105 for most spaces, which would be around 20 degrees Celsius, then that motor is likely running too hot. So you do have an issue. Maybe the little fan at the back, it's all plugged, the little grill is all plugged, or the space is too hot. So you do have an issue. There's other reason why it could be running that hot. It could be a voltage imbalance in the three-phase that could, if it's a three-phase motor, that could lead to this kind of hot operation of the motor. But that's one item that's often overlooked. And if you do have that little infrared camera, the diagnostic can be done once a year very quickly on all your motors Just provide the right tool to your operating team. Like I said, we need to remember motors don't like heat, and that is one of the reasons when you have a VFD, you don't want to slow it down too much, especially if that motor is running in an enclosed space without proper ventilation, and it's, let's say, a hot water pump. It's already hot because of the liquid that's in that pump. So that motor can actually get even hotter. And if you run it at 10 hertz, it's likely going to overheat the winding. So those are the things to look for when you're talking about the actual motor reliability in regard to its temperature. There's other potential issues if we look at fan motor, and some of those will actually apply to pumps if they are belt driven, even though most pumps are direct driven. But there's a bunch of issues that need to be part of your PM program when we talk about belts. Your PM program will have change the belts. Everybody change the belts. Most people will change the belts, but there's other things to look for. When you change the belt, you need to make sure that there's proper alignment between the sheave of the motor and the fan. And there again, the table, I'm not going to read everything in that table, but this table provides you the effects. So what you can use to diagnose a problem with misalignment of your motor sheave and your fan sheave. And you want that to be properly aligned. Sometimes you get tensile failure of your belt. That's usually a good sign, a very good sign that you have misalignment. If you see that your belt are wearing too fast, if you see like black dust at the bottom of the belt, that's usually a sign of misalignment. And then you also have the belt tension that needs to be looked at. So if you see that you have belts, and when I do energy audits or recommissioning, sometimes we see the belts are fluttering all over the place. That is improper belt tensioning. So you gotta have proper alignment. And again, we have in the slide the main point that will allow you to say, or your operators should be aware of that. Why do I have belt misalignment? It's because of those possible cause. If you see premature belt failure, belt dust, if they're not equally stretched, that would be misalignment. Hopefully you do have a tool to verify the tension. That should be part of your annual PM program. Especially for the larger system. Obviously, again, where we do have a slide about PM where it has to be realistic. If you've got too many tasks in your PM program, it's a waste because people cannot get to all of the tasks in your PM program. But belt tensioning for the larger system should be verified. So you put that little tensioning tool there, and depending on the deflection, it will tell you if the belt has proper tension. And like I said, if there's a lot of flutter in the belt, which I see all the time, well, all the time, sorry, I might exaggerate here, but I see often, it's because of improper belt tensioning. All of what we're talking right now will result in energy waste. Improper belt tensioning, misalignment will result in energy waste. Running motors too hot will reduce its efficiency, energy waste. So basically, almost all of what we're discussing today will result in energy waste. And actually, in the last section, we do quantify that, obviously, based on different case studies, of how much you can gain in energy efficiency just by proper diagnostic and preventive maintenance to prevent failures of your system. So belt tensioning, belt alignment, we talked about that. Sorry, I'm going fast because, like I said, it's a very big topic and we only have so much time available. When you talk about pump, most pumps are not belt-driven, they're direct-driven. If you do have belt-driven pumps, then the same things will apply about the sheave being properly aligned. That table will provide you with the diagnostic or how to diagnose if it's not properly aligned. If you have directly driven pumps, most pumps are oversized. It is very rare that engineer will install a pump that is exactly what the system needs. Because if they made any kind of underestimation, they end up with a pump that's too small for whatever service it's supposed to provide. So you should always know that in your building, all your pumps are likely slightly oversized by a safety factor. So how do we resolve that? There's two ways to resolve that oversizing of a pump. You either throttle the pump, which was the old-fashioned way. You get the balancer to come in. The balancer takes the delta P across the pump, says, that delta P is too low. I need to throttle the pump to go to the delta P that the design engineer told me to get. So that's why you see the 2 gauge I put on this slide. You need to check what is the delta P across your pumps. That's one way to make sure the pump is right size to your loop, to your building, is to throttle the pump. The other way is to put a VFD on the pump. Doesn't mean it's going to be also properly sized. You also need to measure under the normal VFD speed operation, the more common one, what is the delta P across that pump. Now you check that delta P that you have against the nameplate delta P. If you're dead on, so you got exactly the head that was supposed to be, your pump is running at its best efficiency point. And that's what you want. But the best efficiency point is also the best reliability point. So on this graph, what you see is what happens to the reliability of your pump when you are not running where it's supposed to be running, which is its best efficiency point. They will always be selected for a given application to run in their best efficiency point. So if you read, give you an example, you read on those gauges 60 psi, and that 60 psi is way lower than the actual design head. Let's say the design head was 80 psi, you're running at 60 psi. What happened is you're moving from here, you're moving down here, and your flow is going to increase because your head is lower. And the consequence of that is your bearing life will go down and you'll have more leaky pump. The seal of the pump will also not last not as long. My colleague, Stephen Dixon, always says, show me your least reliable pump. The one that the bearing goes all the time, the one that the seals are always leaking, that pump is oversized. So make sure that part of your PM to verify that the pressure drop across your pump matches the nameplate. If it doesn't match the nameplate, you can throttle it, which is not very energy efficient. Ideally, you put a VFD on it, and then you can run in that sweet spot where it will be efficient and reliable. So that graph will give you what happens if your head is too high, if your head is too low in terms of reliability of your pump. Head is too low in terms. Sorry? Okay, I thought I heard somebody. So now I talked about VFD. VFD are great. They will provide you a lot of savings, but part of what you have to look for VFDs is that they can also create failure points. And again, you need to address the potential issues with VFDs. Most people are aware that not all motors are VFD compatible. So if the motor should say inverter duty on the nameplate. If it doesn't say inverter duty, it's going to work with a VFD for a certain amount of time. Eventually, the winding will fail, and we'll explain why, but that's something that's going to happen. The other issues that will happen with VFDs, if it's not installed properly, you can get premature bearing failure. It is a very common issue with VFDs is to have bearing failure because there's current, there's voltage that will build up into the bearing, and it will eventually pit the bearing surface. It's called fluting, and it will create bearing failure. Motor winding failure, just talked about it. If you don't have an inverter duty motor, it is likely that your motor winding will fail. And the last one is not a failure, but it's a power quality issue that most people are aware of because of the harmonics that are fed back into your electrical system from VFDs. You can resolve that with proper filtering on the input side of your VFD if you select to install those. If you have a lot of VFDs and you don't have those input filter to remove the harmonics, so those harmonic filters, you may end up with issues with your electronic equipment in your building. So if you've got a lot of issues inside the building with your electronic equipment, you don't know why, and you just installed a bunch of VFDs without harmonic filters, it's likely the cause of it. Bearing failures, like I said, it is something that can happen with VFDs. It won't necessarily happen, but it is possible. What's going to happen is obviously your motor is going to start to get noisy. The typical noise we hear from bearing failure, there's going to be more vibration. On the picture here, you actually see what they call fluting, those little lines that is created in the bearing, and that makes it very noisy. This is due to, like I said, electricity potential building in the shaft and then discharging through the bearing. The best way to resolve that is with usually what we call grounding rings, where you will actually have a ring that goes around your shaft that will be grounded, and it will take care of this electricity buildup or this voltage buildup in your shaft. Instead of going through your bearing, it will go through basically this grounding loop. There's different ways of resolving that, but if you have repeated bearing failure after the installation of VFDs, it is because of this VFD-induced current in your bearing, and you need to resolve that by proper grounding of the shaft. Like I said, you can look at those grounding rings, those low impedance grounding strap that you see on the picture here. So there's different ways to do it, but you need to make sure that this current that builds up because of the VFD in the shaft will be grounded.
So Michelle, time check is 10:32 right now.
Okay, thank you very much. So very quickly, other problem with motor winding damage and power quality, a VFD will have much higher voltage peaks than a motor that's run on without a VFD. So that's why you need an inverter rated motor, because the non-inverter rated motors will overheat the winding. The winding insulation is not as good, the thermal insulation, and it will short. So that's the reason why you need those inverter ready. You can use the infrared camera, check your surface temperature of your motor. It's class F. If it's above 105, you know that you're on a trend to burn out the winding. So that, again, if you've got the proper tool, it can be diagnosed. You want your VFDs as close as possible to the motor. The further you are from the motor, the more those peaks will be high. So even an inverter duty motor can burn out if your drive is installed way far and you've got this long lead and you don't have an output filter. What they call, sometimes you'll hear maybe the term DVDT filter. That will help to reduce the issues with long leads. So if you cannot install the drive close to your motor, and this has nothing to do with the previous problem, which is the grounding. This is a different issue, is about the high peaks. You've got a VFD that's far. It's going to send you high voltage peaks to your motor, even if it's inverter duty. So you will need to have a filter, that an output filter, which is called a DVDT filter. It's not the same as your input filter, which is for your harmonics, usually on the output input side, to ensure that your electronics are not impacted by multiple VFDs in your building. I'm going to kind of skip this one, thermostat issues. They're not that common, like I said, in a smaller building. I'll let you read those slides on your own. If you've got ACs, air conditioner that are not a chiller, we're talking about more the type of rooftop unit, the split systems. Obviously, they're motor driven. The compressor has its motor that is hermetically sealed within the compressor. Usually, the biggest culprit in failure of those is improper maintenance of the coils. Besides refrigerant charge, which we'll talk about later. So you got to make sure that you minimize the lift. The lift between is the difference between the evaporating temperature and the condensing temperature. If you've got improper airflow on your coils, if you got dirty coils, that will increase the lift. As the lift goes up, your compressor has to work harder. As it works harder, it has a tendency to overheat, and it will create failure. That if it's a water-based system, obviously the water flow is the same as airflow. So improper flow, it can sometimes, but rarely, be an electrical issue, just like we talked about the motors, where you have either your voltage is too low or you've got imbalance phases. It is not the most common reason, but it's something you make if you see that you've got systematic issues with your compressors, your motors, they're all burning out, and you check your voltage, and for some odd reason, it's a lower voltage. There's always that rule, voltage low, amps high, and the amps are the one that creates heat. So you want your voltage to be close to the nominal voltage so that your amps go down. So there's always this relationship between amps and voltage. It's usually not something that you would put in a PM program to check the voltage. It's only when you see that there are systematic failures within your building of motors, and it's when you cannot relate them to any specific cause. It's a systemic cause, which usually is from your electrical supply. Excessive noise during operation. Again, I'm going to let you read that one, but there is a few things that are not in here that I see during recommissioning. Sometimes excessive noise is due to fire dampers partially closed. I've seen dampers that were actually in an air handling units that were all closed at the same time because of improper installation of the actuators. They were in reverse order. And then you get this really thumping noise from your HVAC system. So if you hear a lot of excessive noise, especially when it's air noises, it's usually linked to velocity. Obviously, there's other reasons such as leaks. On that aspect, the one thing I want to mention, I think we do have that later on. Most buildings, 70% of commercial buildings have high leak from their distribution system. And when I say high leak, it's 10 to 30%. 10% to 30% of the air that you send in your ductwork is lost. And often it can be lost through small opening. And if your pressure is high enough in your ductwork, it will create noise issue. So don't think that 100% of your air going into your ductwork gets into the space. On average, it will be 70 to 90%. And you can test that. That's not, again, it's not something you would do as part of a PM program because it's too much work, but you would do that part of a recommissioning where you would actually check what is the leakage from your ductwork, and then there's solution to that, but they're more capital intensive. A very frequent issue that you would have that you need definitely to address in your PM program is water. It says water leakage, but sometimes it's water accumulation. It's water carried over through your system. Anytime you have water sitting in an HVAC system, it is a sanitary issue because you will have mold growth. You can distribute that mold throughout the building. So it has to be really a very important point in your PM program to make sure that all the drains are properly clean. You may need UV treatment on your cooling coil, and that has nothing to do with virus, by the way. It does not do nothing for virus. It's about eliminating mold growth. And make sure that the velocity is not too high. Sometimes there's restriction that will make the velocity through your cooling coil too high, and it will carry over the condensate, which can accumulate on the air handling unit floor, and it can create mold issues. So there's different things that need to be verified. Make sure that part of the PM is not only to clean the drain, but to verify that there's no signs of condensate accumulation anywhere, or if your humidifier is over humidifying, your humidity sensor on the discharge is not reading properly, you may create puddles in your ductwork because of over humidification, because of one bad sensor that would be your high limit sensor, which is similar to what we see here per humidity control. Most commercial building, their humidifiers are no longer working because they're such a pain to maintain. But if you do have a working humidification system, those sensors are critical, because if you provide too much humidity, again, it's a health concern, because too much humidity means potential for mold growth. So it needs to be part of what we call the critical sensor calibration plan, which should be part of your PM program for the BAS. Quick words about the refrigerant and airflow. We already talked a bit about refrigerant and also a bit about airflow. This is not exactly like electrical, where you always call an electrician because you don't want to take the, you should never take the risk of working on electrical. On the refrigerant side, you will unlikely do any work that requires actually going into a system, recharging the system. This is very specialized work that will be done by the refrigeration technician. But you should be able to diagnose what is the most likely reason of an issue. The most common issues with refrigeration system, and when I say refrigeration, I mean air conditioning, by the way. I don't mean like refrigeration as we see in a cold room. So low refrigerant charge and high refrigerant charge. The overcharge system is the least common of the two. The low refrigerant charge is by far the most common. Usually you'll see that, especially on DX system, and most operators will know that, by frozen evaporator coil. That is the dead giveaway. When you have low refrigerant charge, you will have a very easily frozen evaporator coil when it's a DX system. And you will lose a lot of capacity. As you lose refrigeration, your system will lose capacity, so you can no longer provide enough cooling. And eventually, to try to compensate, it keeps getting the evaporating pressure lower and lower, which creates freeze-ups. And you'll see a lot of freeze-ups on your lines, on your evaporator. When you're overcharged, you may sometimes see freeze-ups, but most of the time what you'll see is really high head pressure, because all of that extra refrigerant goes onto the condenser side, which means it reduces the effective area that you have on your condenser. It will reduce what's called your subcooling. So if your operating team knows how to check for the compressor high pressure, how to check for subcooling, and they see they have very low subcooling, and they have very high subcooling and very high head pressure, they know that they are overcharged. And now you can actually call the refrigerant tech and tell them, we're almost certain that we have a overcharged system. Can you come over? So those are really issues to help you know what's going on with your system, knowing that you're unlikely to fix that without that third-party contractor coming in to do the work, unless your team has the proper expertise in refrigeration system. So again, little table that will help you do diagnostics on your refrigerant if you've got fixed metering system, which is not that common in commercial building. You usually will have more of an active system. The fixed metering system is a capillary tube, where most of our systems that are DX will have TXV or electronic metering valve. So this table would be more appropriate for most of your system. And here's an example of that really, really frozen evaporator coil. Other issue we want to talk about is airflow issues. If you've got low airflow, it can be due to a lot of leakage in your ductwork. You may have tenant fit-ups and people will push a VAV box in the ceiling space. It's no longer providing air to the space. You may have flexible ductwork that's disconnected. So all of those are very common issues that will reduce your effective airflow delivered to the space. There are obviously the other ones that are very common, clogged filters. It could be dampers that are not reacting properly to the BAS command. You will have fire dampers that could be partially shot. All of those can definitely be diagnosed And for a lot of those can be fixed by your in-house team. A little quiz here. When you have a clogged filter and you change with better filters, with new filters, I wouldn't say better, but new filters, if your system is constant flow, it will increase the flow, it will increase the power usage. The odd thing about filters that are dirty, they save energy in terms of how much fan power is being used. It's a bit counterintuitive, but if your system is variable speed, it's the total reversal. You will spend a lot more energy on your fan with dirty filters on a VAV system. Whereas for a constant flow system, dirty filters will create all kinds of issues with air quality. You may not be able to get enough cooling, but in terms of fan power, it will actually use less power with clogged filters, which is kind of odd, but it's always something that is good to know. You don't leave clogged filters, don't get me wrong, but you need to know what the consequences are when you change that, is to improve air quality, improve cooling capacity and heating capacity, but not to save fan power. If you've got terminal unit, that is a bit, I won't say a nightmare, but you may end up with 200, 400, 1,000 VAV box in large buildings, and those VAV box will have failure. And it is very difficult to have a PM program that will go box by box unless you got, a big team. So in practice, what you have to be aware of is how to diagnose failure of VAV boxes. The more common failures will be obviously an actuator failure, or it could be one of those old plastic tubing that failed, that disconnected, or that has an air leak, and you no longer get the proper flow measurement from that VAV box, which will result in airflow issues in the zone, people being either too cold or too hot, and that's when you will need to have a tool, and I'll show you a tool that we will provide you that can help you, and unfortunately it's just for one type of system. Just give me a sec here. So what you see on the screen is a little tool that you'll have. PureAscent will distribute that once I'm done. I still have to do a few things on it. You can go in a space, measure the temperature of the space and the humidity of the space. Now, talking about that, make sure when you do your diagnostic, don't ever use this to measure space temperature. This is an infrared gun that is no good for space temperature. It measures surface temperature. It's absolutely invalid for air temperature and comfort measurement. You need to use something like this. It has a thermistor and it will measure temperature and humidity. Do that. Make sure your operators know that they have to use something like that. You enter the humidity and the temperature. It will tell you, am I in the comfort zone of my building? The red box is the heating comfort zone that you can actually customize to your building. And well, this tool was developed for a VAV system serving the interior of a building and an induction system serving the perimeter. Did not have time to generalize it to all kinds of systems. So you will enter the type of complaint that you have, where it's located, either perimeter or interior, what the mode is, and then you say what it will tell you what the possible reason for this and the cause to investigate. You'll say, hey, it's likely this, or this. And it will do that for drafty, too hot, too cold, and it will allow you to kind of guide your investigation on that system. So VAV box, many of them, very difficult. There are PM action you can take that's usually done within a recommissioning, but you can take those actions for VAV box where you will use your BAS to once a year to diagnose how many VAV box are not working properly. Very often during the year, you will identify that through the complaints. But if you do that test, and PureAscent, I will send that along with the tool, which is the functional test that can be done as part of a PM program, to try to identify VAV box, actually not try, to identify VAV box that you know for a fact need to be, let's say, verified and fixed. I'm going to skip the negative air pressure. Well, I'm not really going to skip it. The one thing I want to mention about that, if you say, I've got a problem, my building's always negative, it is unlikely you can ever resolve most negative air pressure, especially on a high-rise building, with your HVAC system. Negative air pressure can be, in terms of pressure measurement, in the 200-300 Pascal level. Your mechanical system, for most buildings, cannot provide pressurization more than about 40 Pascal. So if you try to basically throw a lot of outside air to try to pressurize your building, you are basically wasting energy because you will not win that battle. The best way to resolve negative pressure issues, especially in a high-rise building, is to reduce the infiltration, because your mechanical system will not win that battle, especially if there's any kind of wind. Wind loading is 10 times, 100 times stronger than what your HVAC system can do. So if you've got a real issue with pressure, your first course of action is to go after the building envelope. So for the zone temperatures, it's the tool that I showed you that we're going to provide you, along with a possible functional test you could do once a year to identify the boxes that need to be looked after, to be resolved where there are issues. If you've got a FDD, a fault detection and diagnostic system, it will likely provide you the same kind of information if the FDD is well commissioned and working properly, which is a big if. So that brings us to control issues. The number of control issues that you can have in the building, just like the other issues we talked about today, is near infinity. There can be so many issues. So the first course of action that you need to take is don't trust all of what you see on the BAS. I always say, when you're in a room and you've got the operator and you've got maybe your EBCX provider, I always say the biggest liar in the room is the BAS. I never trust the BAS until I verify it. So how do you verify it? You will have to have a proper PM program just for the BAS. That usually takes the form of a service contract with whomever installed that BAS. Now, the one thing you have to be very careful about, they will sometimes say, we're going to calibrate all the sensors once a year. That is usually not done because there's too many sensors. Make sure that if you do have a PM program for your BAS, that you have what's called a critical sensor list. What are the most critical sensors in my building? The one that have the more influence on my energy use and on the reliability on my system. Make sure that those sensors are part of your service agreement, and those are verified very rigorously once a year or twice a year, depending on your contract, by your service provider.
Michelle, we have 7 minutes left. Sorry.
I'm sorry?
We have 7 minutes left.
Okay, we're going to be okay. So once you've got that, you got the right sensor and you still have issues. You got short cycling. We talked about short cycling can reduce the life of your motors, of your contactors. So you have obviously all of the BS logic to look after. So you want to make sure that there's always deadband in your system, that your PI loop have been optimized. So the best way, again, to resolve those possible issues would be to do an EBCX if you could. If not, you have to have a systematic approach, which is usually based on functional testing. You say, well, you know what, we cannot do an EBCX because the funding for us is not there, even with the incentive. Then make sure, say, what is the most critical control sequence? Which one do we see hunting all the time? That motor starts and stops. And don't just guess what the solution would be. You test it and then you implement it. That's actually the basis of EBCX. Another sign is to look for overrides. You see on that screen, there's 2 overrides on critical component. The override is on the damper for the VAV box and on the reheat coil for the VAV box. And those 2 settings are incompatible right now. But before you remove that, so identify all of the override, and then your operating team needs to say, why do we have this override? We need to resolve the root cause before we remove the override. So part, again, of your PM program for the BAS would be to always have a report of what points are in override. And then identify the root cause and when will this override be taken out, because the overrides basically take away the value of your BAS. The more overrides, the less value the BAS that you paid for has. And talked about the sensor. So obviously sensor inaccuracies, sensor failures would be captured through your critical sensor calibration plan that you should have as part of your PM maintenance. There's a little graph here that I put in because a lot of people think that accuracy and precision means the same things, and it's not. What we want on our BAS, we want to have some sensor that's very precise, because that's the one at the top here. It's very precise. Every arrow are in the same location, and then you can easily correct that. But what we do in a BAS by putting a bias, and that brings that value to the proper value. So make sure that you have very precise sensors, and the accuracy can be corrected by calibration through bias. And that brings us to that very quick last section. I talked about it already. You need a preventive maintenance plan. You don't want a reactive maintenance plan, because that is actually not a plan. You just react to failure. The PM program, there's lots of resources to have a proper PM program, but keep it realistic. Always know what your resources are, what they can achieve, and then prioritize everything that has a high impact on tenant comfort, on reliability of the equipment, should be at the top. And then energy efficiency should not be necessarily what creates the top preventive maintenance action. It should be reliability, it should be tenant comfort, and efficiency will come along with that. Usually, if you have a proper PM program compared to no PM program, to a reactive PM program, your savings will be in the 5 to 20% range. And if you if you had just purely reactive and basically very little in terms of even, I'd say, informal PM, you're likely going to be close to that 20% rather than the 5%. And there's a few examples provided to you here. But like I said, there's a lot of resource, and PM programs, they need to be adapted to your building. If you take one from another building and you apply it here, it's not going to work perfect. It wasn't not going to work as well as if you adapt it to your building. You've got your own systems. You know what are the priorities for your system, what are the more important ones. So you need to make sure that PM program is adapted for your system. And again, make it realistic. Make sure that I've worked in a large building downtown Toronto. They had a large PM program, and at the end of the year, there was still 3,000 open work order on that PM program because they could never get to the end of it. So that was getting to be useless. So have a useful PM program. There's different signs that PM programs are due to be reviewed, maybe in the building. So you have your PM program. It should not be static. It should be a living document, in the sense that it needs to evolve with your building. You will discover that there are issues that creep up all the time. Maybe it's time to review your PM program in terms of priority. So I know we went quite fast. There's a lot of different issues that can pop up in the building. We will provide you with that tool, that little Excel tool, and along with the test that you can do if you've got VAV box. And remember, the PM program is at the basis of all what we saw. How to avoid having the failure is to have the PM program. The PM program needs to address a lot of what we saw today to intercept that before it becomes a problem. And it's not an expense. It should always be seen as an investment. And then DBCX will definitely help you if you can afford to do one. If you do go down that route, make sure that it is on the radar of your EBCX provider, that he needs to look at your PM program and see if there's reprioritization that needs to be done or new items that need to be added to your PM program. And that's it, President. I know I was supposed to leave 5 minutes and I left like 1 minute.
That's fine. We apologize for being very close on time. If you just stay for 5 more minutes, we can answer all your questions. There are some questions that have been asked so far. So Kyle asked the question, is there a low-cost infrared camera you can recommend, and what's the rough cost?
So the little infrared camera that you put on your phone, I use two kinds. I have a FLIR, It's called Fluor One, and I've got this one here, which is called HIK Micro, which is probably a little bit of a lesser quality, but I love it, that one, because it used the battery from the phone rather than its onboard battery. And the Fluor, I always had an issue with the battery not lasting very long. But there's a lot of good product out there. They're around $200 to $300. They're not expensive, and it is worth it's more than worth its cost. It's really useful for doing diagnostics of multiple things. Like you can use it on your coils to make sure that heating, cooling coils don't have block circuits in there. You can use it on your panels. You can use it on motors. So a lot of use for it, and a couple of $100, maybe 300 at most.
Okay. And the next question was from Gabrielle is the common minimum VFD output 20 to 30% enough to avoid pumps or fans from overheating?
It depends on your application. If you have a cooling tower, 15 hertz is often the minimum speed. When your pump is cooled, either by a big airflow, like in a fan, you can go to about 15 hertz. When your pump is pumping hot liquid, like hot glycol, hot water, and it's in a normal environment, you probably don't want to go lower than about 25 hertz. 25 hertz would be the minimum. But like I said, for cooling towers, because of the airflow around the motor, usually you can go lower to about 15 hertz.
Okay. And the next question we have is the units for the measurement for the reliability curve.
So the reliability curve for the pump, you've got the head on the side there that's in feet of water. Sorry about the units being imperial here. And you have gallon at the bottom. So you got gallons and feet. And every pump that you have if you've got a pump curve, it will always be that. I mean, it could be in meter cube second or in kPa, but usually our pumps are in imperial system. So you'll have feet of water on the one axis, and at the bottom it will be gallons per minute.
Perfect. And then the next question from Matthew is, do most modern VFDs come with built-in harmonic filters?
It doesn't, you cannot assume that it will. A lot of the good quality one will, but it is not systematic. So you do have to be careful and you have to check. But I'd say a lot of the good quality one will.
And then another question, final question is from Kyle. Is there a rough cost for EBCX investigation? No implementation per facility? I imagine it's very dependent on the facility, but curious on a ballpark value.
So the ballpark, I have no problem. I'm going to tell you the EBCX cost without the implementation, because you do have to pay to implement measures. So if you take the whole EBCX project, plus you'll have to keep some money for the paying for the implementing measures, you're talking about 30 cents per square foot typically for full recommissioning. You will get people to provide you quote for much lower because they will do less than a full EBCX. So anything below 20 cents, you got to be very wary about, because below 20 cents per kilowatt hour per square foot, that means they're going to have to skip some of the actual EBCX, or they're going to have a smaller scope of work than the full building.
Perfect. Thank you, Michelle. Is there any other questions from anyone in the audience? I know we're 3 minutes over time.
It's my fault. And you did warn me, Puracent, twice.
It's okay. We had a lot of good content from you, so that's more than enough. Okay. Yeah, just hearing a bunch of thank yous. I think there are no other questions for now. But if you do have any questions, we'll stay for a minute or so. If not, thank you so much for attending, and thank you, Michelle, for the great presentation.
Thank you, guys.
If you can go to the next, the very second last slide, Michelle.
Oh, yeah, sorry.
Yeah. So yeah, to answer some of the questions too, yes, slides will be posted later this week. So they'll be also on the Save on Energy training support link right here. And then
if right here, yeah.
Yep. And then if you can just skim through it, these slides will be provided at the second last slide, the one with the survey. Keep going. Yep.
This one, eh?
The survey one. No, the next one. Yep. So no worries. So we'll be sending a survey at the end of the presentation. It'll take about 5 minutes. Please provide your feedback. It helps us a lot. It helps Michelle, myself, and our team create better webinars for the future. So please take at least 2 or 3 minutes just to respond to the survey. And yeah, thanks so much for attending. Thank you, guys. Have a great day. Thank you.